NASA's Lucy mission there, an ambitious endeavor to take us to some fascinating destinations. Here to tell me more about this extraordinary mission and its equally extraordinary targets, I'm joined by Lucy's Deputy Principal Investigator, Cathy Olkin of the Southwest Research Institute. Cathy, welcome and thank you so much for joining us today.
Hi, Stuart. Thanks for having me.
It's a pleasure. Now, the Trojan asteroids, I mean, goodness, even the name sounds exotic, and I am betting there's some pretty big secrets out there to be revealed.
I think that's exactly it. They're mysterious. We've never sent a spacecraft to the Trojan asteroids before, and I can't wait to see what we're going to see when we get there. Anytime we've looked at a new population of objects, it's really advanced our understanding of our solar system. And these Trojan asteroids, I expect, will be the exact same thing.
Now, Lucy's all tooled up as well to sort of really get the details. Tell me a bit about the instruments and the measurements you're going to be taking so that you can build up this picture of this new family of asteroids.
Yeah, I like to think of our instruments as the eyes that we're going to have on the Trojan asteroids. So we have three scientific instruments. LORI, which is kind of a small telescope that'll give us black and white images, high resolution images, so we can learn about the geology of the Trojan asteroids. We have the Ralph instrument, which is really two instruments in one. It's going to give us color information, so visible color, and then infrared spectra so that we can understand the composition of the surface. And then the TESS instrument will help us determine the temperature of the surface, and also a property of the surface called thermal inertia, how well the surface retains the heat. And also something we're doing interestingly is that we have two of the subsystems on the spacecraft are going to contribute to our scientific return. We have terminal tracking cameras that will help us keep our scientific instruments pointed at the target. And these terminal tracking cameras will also help us to understand the volume of these Trojan asteroids. And our telecommunication subsystem is going to help us understand the mass of these Trojan asteroids. As the spacecraft flies by, the gravitational pull of the Trojan asteroids will change the velocity just a little bit of the spacecraft. And we'll be able to measure that with the Doppler signal through our radio subsystem. And that's going to be so exciting. And we can combine the mass and the volume to understand the bulk density of these objects. So there's a lot of investigations we're going to do across a large part of the electromagnetic spectrum and really getting a broad look at the surface properties and interior structure of the Trojan asteroids.
One of the things that I love so much is how creative scientists and engineers are when they make these missions. So, you're describing using these subsystems which are there for telecommunications and navigation, but you can extract science out of that as well. It's just squeezing every little bit of information out of every bit that you get back. I just wonder, out of all the breadth of everything you're going to be looking at, if you could know one thing about the Trojan asteroids at the end of the mission, what would that be?
Probably the thing I'm most excited about learning about these Trojan asteroids is the composition. What are they made out of? And so there's the surface composition, which we'll get from the infrared spectra, and we'll be able to look at minerals and organics and ices. And then also the bulk density gives us information about the composition. So I probably picked two things rather than the one you were asking, but those are the things I'm most excited about learning about the Trojan asteroids. And the reason I really want to understand those parameters is because that helps us understand where these objects came from, what their history was. These are really the leftover building blocks of our planets. And so really understanding this small body population is going to help us understand the evolution of the solar system.
Well, after all the work and the dedication that you've put into this mission, I think we can allow you two things rather than just the one.
Thank
Now,
you.
you're looking very calm at the moment, which is quite interesting because you're racing towards the launch at the end of the year, and I imagine there is 1,001 things to do. Bring us up to date with what the current status of Lucy is.
There are so many things going on right now. You are exactly right. And it's a very exciting time. For a long time, the mission concept was just that, a concept. It was on paper and it was an engineering design, computer aided models, things like that. Then we got to be actual physical hardware. And right now, all of that hardware is assembled as the spacecraft. And we've been through a lot of our environmental testing program. So we've done vibration tests, electromagnetic tests. And right now, right today, we are in what's called thermal vacuum testing. And this is going to go on for about a month. And we are going to be testing the spacecraft in a vacuum chamber. So you evacuate all the air so that we can simulate being in space, and we can change the temperature, because Lucy is going to go launch from near Earth, and then go out to near Jupiter. And so that's quite a range of heliocentric distances, quite a range of temperatures. And we're going to test across that temperature span to make sure that the spacecraft and all the systems are going to work well together in the conditions that we need. There's a saying called test as you fly and fly as you test. And it's pretty exciting because that's what we're in the middle of right now. We're testing as we plan to fly.
And it's worth pointing out as well, to any viewers that haven't seen the spacecraft, Lucy has the most beautiful solar panels that have ever been flown into space. It's a lovely looking spacecraft.
Yeah, they are magnificent. They're absolutely beautiful. And to think that they'll provide the power that the spacecraft needs so that we can get those eyes on the Trojan asteroids and get that data back to Earth. It's all quite remarkable and very exciting.
Indeed, it is. And I can assure you that we'll have eyes on you, having eyes on the asteroids in the Trojan points round Jupiter. So, Cathy, thank you so much for joining us today and bringing us up to date with the mission. We look forward to more updates in the future.
It was nice talking with you. Thank you.